Math 070, sections 5.1 and 5.8. Write the following as fractions and/or mixed numbers. Do not simplify fractions. Look at the first number. It's read 0.45. It is 4 tenths and 5 hundredths. So that is 45 hundredths. If we write that as a fraction, that is 45 over 100. Look at the second fraction, negative 8.4578. We have the tenths, hundreds, thousands, 10 thousandths. So it is negative 84578 over 10,000. Negative 84578 over 10,000. If we write it as a mixed number, it would be negative 8 and 4578 over 10,000. Look at the next number. It is tenths, hundreds, thousands, 10,000s, 100,000s, millions. If we write it as a fraction, it is 9, 4, 5, 5, 5, 5, 4 over 1 million. Or as a mixed number, it is 9 and 4, 5, 5, 5, 5, 4 over 1 million. The third number, tens, hundreds, thousands. So it is negative 19,657 over 1,000, or as a mixed number, negative 19 and 657 over 1,000. We want to be able to go the other way and write using decimal notation. So 11 over 1,000. So it has to be less than 1. So it has to be 0. If you recall, the first place after the decimal point is tens, second place is hundreds, and third place is thousands. So it has to have 3 places. That means we have to have 0 in front. 0, 1, 1. So we have tens, hundreds, thousands, 11,000s. We do the same for the next number. If we have 10,000s, so we're going to write it as negative 0. Now 10,000s would be 1, 2, 3, 4. 4 places. We have 3 digits, so it's 0, 8, 9, 7. Tens, hundreds, thousands, 10,000s. Look at the third number. We have millions. That's going to be 1, 2, 3, 4, 5, 6 places. We have 1, 2, 3, 4, 5, so we need an extra 0. 0.068245. And we'll check tens, hundreds, thousands, 10,000, 100,000s, 1 millions. Let's compare fractions or decimals. Which is greater? We look at the two numbers, we want to make them look similar. The second number has 2 digits after the decimal point, so I'm going to make the first one look the same. So that's going to be 16.70. The second one then is 16.75. So this is 16 and 70 100ths. This is 16 and 75 100ths. 75 100ths is bigger than 70 100ths. So the bigger number is 16.75. If I do the same with the second number, to compare, the first number is 142 and 345 thousandths. The second number is 343 thousandths. 142 and 343 thousandths. 345 thousandths is bigger than 343 thousandths. So the bigger number is 142.345. Third number. Now we have to be careful with these because we have negatives. So remember, when you're dealing with negatives, you have to think of things backwards. For example, -3 is smaller than -2. So when I look at this, I have 8 and 98 over 100. So I have 98 100ths, and this is 99 100ths, -8 and 99 100ths. 99 100ths being negative is the smaller of the number. My answer is -8.99. In this course, you have to be able to round to the nearest place value. Again, we have to know our positions after the decimal point. So if it says it's to the nearest tenths, the tenths place is the first digit after the decimal point. Look to the number right to the next to it. If that number is 5 or bigger, then round up the digit that is going to be considered. So the 0 rounds up to 14.1. If I look at the next one, the nearest thousandth, we have tens, hundreds, thousands. I look at the digit right next to it. If that number is 4 or smaller, we keep the interested number as it is. We leave the 7 as is, so our answer is 24.897. Look at the next one. It's the nearest hundredth. Tens, hundreds. Look at the number next to it. If that number is 5 or bigger, then the number that needs to be considered for rounding has to go up. So that means that we have to go 14.57. Round to the nearest 10,000ths. Hundreds, tens, hundreds, thousands, 10,000ths. You look at the number next to it. That number is 4 or smaller. So when the number that has to be for rounding is kept the same. My answer is -2.6765. Translating to a mathematical expression. There's certain vocabulary that you want to recognize, such things as more than, product, less than. When we see more than, as in the first example, that means that we're going to add. More than, 5 more than Ron's age means R plus 5. Product means multiply. So the product of 4 and t means we're going to multiply 4 and t, and we simply write that as 4 times t. Less than means subtract. So 4 less than d. The way we say subtraction is a different order than the way we write the subtraction. When we write the subtraction, it would be d minus 4. 18 subtracted from twice the number where n is the number. Subtracted from is obviously subtraction. Twice the number is 2 times. Remember that subtraction is usually written backwards in the way we write it. So we do twice a number, and then we subtract 18. 1/4 the sum of 2 numbers where x and y are the numbers. In this case, we need to know that sum means add. So we know that we're going to do the sum of 2 numbers. That means we're going to have to add x plus y. We have to be careful here because it's 1/4 the sum. It's 1/4 times all of that. If I simply write 1/4 like this, that simply means 1/4 x plus y. If I want it to mean 1/4 the sum, I have to put parentheses around x plus y. A restaurant owner bought 20 dozen eggs for $25.80. Find the cost of each egg to the nearest tenth of a cent, or the thousandth of a dollar. I'm going to begin by determining how many eggs there are in total. I know that there are 12 eggs in a dozen, so that tells me that the total eggs is 20 times 12. which is 240. I want to know the cost of each egg. So it's price per egg. I need to take then the money, which is $25.80, divide that by the total number of eggs, which is 240, which is 0.1075. The problem asks me to round to the nearest tenth of a cent or the thousandths of a dollar. The number I've just calculated is dollars because I've taken dollars divided by eggs. So then the thousands would be 10, 100, thousands. I look at the number next to it and it's bigger than 5. So that means that the number I need to look at right before that needs to be rounded up. So that tells me I'm supposed to go 0.108. Again, that's dollars. To convert that to cents, I move the decimal point 2 places. That tells me that each egg costs 10.8 cents. Claire bought a book for $16.95 plus 85 cents sales tax. She paid with a $20 bill. How much change did she receive? Let's first calculate how much the book will cost her. Let's calculate $16.95 plus the 85 cents in tax. This is a total of $17.80. Her change is then the difference between $20 and $17.80, which is $2.20. Ian spends twice as long on his homework as he does on his history homework. 1 week he spent a total of 10.5 hours on science and history. How much time did he spend on each subject? Since science is in terms of history, let's let history be the variable. I'm going to make that H. H equals hours spent on history. I know that he spends twice as much on science. Twice means 2 times. So 2 times H is hours spent on science. Total means add. So if I add the hours spent in history plus the hours spent on science, H plus 2H, that's total, that has to equal 10.5. If I have 1H plus 2H, I have 3H. That has to equal 10.5. I'll divide both sides by 3 because the opposite of 2 times is to divide, and this cancels out the 3 on the left side. That now tells me that H is 10.5 over 3, which if you put that in your calculator, you get 3.5. I now know that he spent 3.5 hours on history. Science is 2 times that. 2 times 3.5 is 7.0. So he spent 7.0 hours on science.